you by thesis123.com. I learn and teach online.
Here's the next question, number 15. The inductance and capacitance of a 400 kV 3-phase 50 Hz lossless transmission line are 1.6 millihenry per kilometer per phase and 10 nanofarads per kilometer per phase respectively. The sending end voltage is maintained at 400 kV. To maintain a voltage of 400 kV at the receiving end, when the line is delivering 300 megawatts of load, the shunt compensation required is A. capacitive, B. inductive, C. resistive, or D. 0. Okay, so first you will have to understand what shunt compensation is. So, shunt compensation is a method that's used to improve the power factor. So, that's the basic definition. It's just a method used to improve the power factor. The closer the power factor is to unity, that's the best that it can get. So, the shunt compensation is a method used to improve power factor. So, when we use an inductive load, or when an inductive load is connected to the transmission line, the power factor lags because of lagging load current. And in order to compensate that, a shunt capacitor is connected, which then draws a current leading the source voltage, and thus that improves the power factor. So, let me just write that down here as well. That's just an example of what shunt compensation is. So, if we were to have an inductive load that is connected to a transmission line, okay, so in this case the power factor lags. For an inductive load, the power factor would lag, and that is because of the lagging load current. And in order to compensate this lagging power factor, we connect a capacitor. So, this draws a leading current. So, here the power factor lags, it's because of lagging current. And if we connect a capacitor, it draws a leading current. So, this compensates the entire system and hence improves the power factor. So, this improves the power factor. So, this is an example of how the system works. So, if there was an inductive load, then by connecting a capacitor, we would improve the power factor. So, here the shunt compensation is capacitive. So, this is an example. Okay, it's an example. Alright. So, now we have to figure out for the question given to us. Now, let's look at the surge impedance of the system given. Now, we have been given the inductance as well as the capacitance value. So, we can find out what the surge impedance is. Let me just get another sheet of paper here. Right. Okay. So, let's calculate the surge impedance. ZS. The surge impedance is given in terms of root L by C. We have already been given the values of L and C, so let's substitute that. L is 1.6 10 power minus 3 divided by capacitance is 10 into 10 power minus 9, square root of that, and the square root of this comes around to 400 ohms. Okay, so we have the surge impedance. Now let's look at the load impedance. The load impedance ZL. So ZL can be calculated in terms of the power that's given. We have been given, let's see here, 400 kV and a load of 300 megawatts. So the load impedance is kV square divided by the load power. So 400 10 power 3 square divided by 300 into 10 power 6. So all these formula here you will have to remember. It's good to keep in mind the surge impedance formula and the load impedance formula as well. Okay, so calculating the load impedance, we get a value of ZL is equal to 533.33 ohms. Now this tells us that the load impedance is greater than the surge impedance, right? So ZL is greater than ZS. Now when ZL is greater than ZS, that indicates that the receiving end voltage will be more than the sending end voltage. So VR is greater than Vs. So in order to reduce this voltage and to keep it to a level of 400 kilovolts, that's what has been asked, see? To maintain a voltage of 400 kilowatts at the receiving end. Now because the load impedance is greater than the surge impedance, we come to the relation that the receiving end voltage is greater than the sending end voltage. So in order to keep the receiving end voltage at 400 kilovolts as what the question says, we would need an inductive compensation. So, but if Vs were greater than Vr, it would be the opposite. We would need capacitive compensation. So, I hope this generalization helped. So, the final answer here is inductive. That's the final answer.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.